students, now in this session I will explain sum number 6 of exercise 6.3 chapter squares and square root. Okay, now in question number 6, the only difference between question number 6 and 5 is that in question number 5 you were supposed to multiply the smallest whole number. Now in this question number 6 you have to divide the required number with the smallest whole number. Okay, the initial process is very similar. Fine. So we have 6 sums in question number 6. So I will explain the first 4 sums. Fine, and the rest of the 2 sums would be your homework, students. Okay. Now the first number is given is 252. Now the first job is to get which is the smallest whole number by which you will divide this number to make it a perfect square. Fine. So for that, what is the first thing we were supposed to do? Yes, we will do the prime factorization of this number. That is 252. Fine. So what is the answer? 2 1s are 2, 2 2s are 4, 2 6s are 12, 2 63s are, then this number is divisible by 3, 21, 3 7s are, and 7 1s are. So we'll write the prime factors. So prime factors of 252 is equals to what? 2 into 2 into 3 into 3 into 7. Now which number is unpaired? Which number is unpaired? Exactly, 7 is unpaired because this 2 and 3 are in the pair form. This number is unpaired. So we have to write what? We have to write here 7 is unpaired. Okay, 7 is unpaired. So the smallest whole number would be what? The smallest whole number is 7. Fine. So now if the smallest whole number is 7, so which with this number we have to divide this given number. Okay. So the smallest whole number is 7, which should be divided by 252 to make it a perfect square number. Okay, so now we'll divide this 252 with 7. 252 divided by 7. So answer will get, what answer will get? 36. Fine. So 36 is the answer. Fine. So the 7 is the smallest whole number by which 252 is divided to make it a perfect square. Okay, now answer is 36. Now we'll get the square root of 36. Okay, so what is the square root of 36? So if we remove this 7 from here, which are the prime factors we left? These are the prime factors we left over. Now you will write 2 into 2 into 3 into 3. So see, these all numbers are in pair form, isn't it? These all numbers are in the pair form. So what is the rule? For each pair we'll take a single digit. That is 2 into 3, and your required answer is 6. Fine. So this is the solution of sum number 1. Let's move on to sum number 2. Sum number 2 we have 2925. Fine. So now the first thing what we have to do, we have to divide this number. That is not divide, we have to do the prime factorization of this number. So it is divisible by 3, isn't it? So 2925 and divided by 3, what answer we'll get? We'll get 975. Now 975 is divisible by 3. Yes, it is divisible by 3. So we'll get 325. Now 325 is not divisible by 3, but it is divisible by 5. So it would be 65. 65 is divisible by 5. So we'll get 13. And at last 13 ones are 13. So prime factors of 2925 is equals to 3 into 3 into 5 into 5 into 13. 3 into 3 to 5 into 5 into 13. Now this numbers are in pair form. So which number is not in pair form? Exactly, 13. So here 13 is unpaired. So what should we write? We write, so 11 is the smallest whole number by which 2925, okay, 2925 is divided, okay, is divided to get a perfect square, to get a perfect square. So this language you have to write. Now we'll divide 2925 divided by what? 13. Fine. So what answer should I get? I will get 225. 225. Now I will get the square root of 225. It's easy. Okay. So what are the prime factors of 225? We can get it from here only because we are removing 13. So these are the leftover prime factors. So we'll just write 3 into 3 into 5 into 5. So these all numbers, these two numbers are in pair form. So for each pair we'll write only one digit. So your required answer is 15. So this is how we have converted 2925 to a perfect square number, that is 225, and the required square root of 225 is 15. Right? This is what we'll do with sum number 3 also. Okay, so let's move on to sum number 3. Third number is 396. So let's do the prime factoration. 396, it is divisible by 2. So 396 when divided by 2, we'll get the answer as 198. 198 is again divisible by 2, we'll get 99. 99 is divisible by 3, we'll get answer as 33. Then 3 11s are 11 ones. Fine. So the prime factors of 396 is equals to 2 into 2 into 3 into 3 into 11. Now the first two numbers are in the pair form, that is 2 and 3 are in pair, but 11 is unpaired. So here 11 is unpaired. Okay, so 11 is the smallest whole number by which 396 is divided. 396 is divided to make it a perfect square. Okay, now we'll divide 396 divided by 11. So answer would be what? 36. And the square root of 36 would be what? So we will remove this 11. So 2 into 2 into 3 into 3. So these are the pair form. So we'll write 2 into 3. So your required answer is 6. Okay, so 396 divided by 11, we will get a perfect square number, and the square root of this perfect square number is 6. Fine. So let's move on to the last sum of our today's session, is sum number 4. Sum number 4, we have 2645. So is it divisible by 3? I guess no. No, this number is not divisible by 3. So directly we'll divide this with 5. So if I divide this with 5, so answer I will get 5 to 9. And students, 5 to 9 is divisible by 23. That is 23 into 23 is 5 to 9. So 23 ones are 23. So prime factors. So prime factors of 2645 is 5 into 23 into 23. So 23 is in the pair form, 5 is unpaired this time. So we'll write here 5 is unpaired. Fine. So 5 is the smallest whole number by which 2645 is divided to make it a perfect square. Okay, to make it a perfect square. Now we'll divide this number. 2645 divided by 5. So we'll get 529. And what is the square root of 529? Square root of 529 is what? We'll write these two factors, that is 23 into 23, and we'll get answer as 23. So this is a required answer, students, and the rest two sums 5 and 6, try it on yourself. Okay, thank you so much. God bless you all and stay blessed. Tata.